Good evening, everybody. I would like to welcome you to another online review session. In today's session, we are going to discuss the chemistry of alkenes, which will be taken from the end of chapter questions. Before we start the session, let me go ahead and acknowledge those of you who have already joined us. I see here Alfreda Woods, Iria Waller, Brianna Neal, Ellie Rono, Divani Mowat, Ines Kifando, Jenny Jones, Janelle Iradiri, Kiani Walker, Kiera Bradley, Lorena Ed Williams, Makamba Saki, Mata Margaret Cotton, Oyin Olusheye, Pravin Cheka, Shikira Hudson, Taylor Wright, and Tiffany Farrell. You are all welcome. Oh, I also see here Tudi Wilson is also joined us. Okay, you are all welcome. So we are going to start the session right away because I do want us to get out of here exactly at 9 o'clock tonight. If you all know that the first presidential debate is on tonight and it will be starting at 9. I'm sure most of you would like to watch that debate. So let me call on Praveen. Go ahead and read this question for us.
It says, name the alkenes below.
Okay, very good, and thank you. Okay, what they want us to do here is to name the following molecules. These molecules are alkenes. Of course, you can see here, the alkenes are characterized by the presence of the carbon-carbon double bond. So we have to name this molecule. We also have to name this molecule right here. In this molecule you see here, the carbon-carbon double bond is in a 6-membered ring. So let us go to my notebook and then we solve these problems together. Okay, this is the first of the molecules. What I'm going to do here, let me go ahead and write this molecule in a 2-dimensional orientation right here, so we could actually work on these problems together. We start with the carbon-carbon double bond. And then to that carbon-carbon double bond you have a methyl group attached to that. That is this right here. And then on this carbon here, you have another methyl group. And here you have another methyl group. And now you have a CH2 attached to this carbon here. And to that is a methyl group. Okay, so let us go ahead and name this molecule here. The first question I have for you is, what is the longest carbon chain that contains the carbon-carbon double bond? What is the longest carbon chain that, okay, 5. Very good, very good. Okay, so the first thing you do is to number the longest carbon chain which contains the carbon-carbon double bond such that you give the carbon-carbon double bond the lowest possible number. So this is position number 1, position number 2, 3, 4, and 5. So what would be the name of this compound? which means that we have branches in this position here, a methyl branch in position number 2, and another methyl branch in position number 4. No, I'm sorry, in position number 3. So what will be the name of this compound? 3-ethyl-2,3-dimethyl, 2,3-dimethyl, 2-pentene. Okay, exactly, very good. 2,3-dimethyl, 2-pentene, exactly. That is correct. Somebody is asking a question. Could the top left? No, you have to number from here because you want to give the carbon-carbon double bond the lowest possible number. Somebody is asking a question. Can we start numbering from this carbon here? And the answer is no. You have to start numbering from here. Okay, so the name therefore is 2,3-dimethyl, and then you indicate the position of the double bond, 2-pentene. Okay, so that is the name of this molecule. Okay, I believe everybody is okay with that. Okay, let us go to the next one. Okay, here we also have to name this molecule here. In this molecule, you have a 6-member ring, and the carbon-carbon double bond is within the 6-member ring. So let me go ahead and write the structure here. So we have 6-member ring, and then you have the double bond here, and then attached to the double bond you have a methyl group right here, which is this methyl right here. And then on this carbon here you have an isopropyl group. This group here is what we call the isopropyl. Anytime you see this group, a CH attached to 2 methyl group, and this carbon here is attached to another group here. This is called an isopropyl. Isopropyl. Just as you have a methyl group, you also have an isopropyl group. Okay, so what will be the name of this compound? Keep in mind, in this case, you also have to assign the lowest possible number to the carbon-carbon double bond. Whenever you have a ring system, the carbon-carbon double bond will be in positions 1 and 2. Whenever you have a ring system, the double bond must be in positions 1 and 2. And in this case, since this carbon here is attached to a methyl group, this carbon has to be carbon number 1. Okay? Okay, so let us number this. This is carbon 1, therefore this is 2, this is 3, this is 4, this is 5, this is 6. Okay, and the branches are, I think somebody has already told us, the branches are the isopropyl group in the 6th position and the methyl in the 1 position. So what do we have here? Somebody say 6 isopropyl, 1 methyl hexene. Excellent, that is correct. So let us write that down. That is 6 isopropyl. Keep in mind you have to use the alphabetizing order also. Isopropyl, and then one methyl. Keep in mind the isopropyl come before the methyl, cyclohexene. Okay, cyclohexene. Okay, let me write that better. Let me erase this. This is clogging up this place here. Start from here. 6 isopropyl one methyl cyclohexene. Keep in mind when you have the cyclic ring system, you do not have to indicate the position of the double bond because you assume that the double bond will be in position 1 and 2. Okay, let us continue. If there is no question. Okay, we want to do the same for here. Okay, let us look at this molecule here. We have how many carbon do we have in this molecule? Okay, somebody is asking a question. So the question is when you have a cycloalkane, you don't keep counting afterwards. When you have a ring system, the point is that the carbon-carbon double bond will be assumed to be position 1 and 2. Okay, so let us write this structure here. Okay, somebody say if there are 2 double bonds, then what will you do? That is an excellent question. Okay, before I do this, supposing you have 2 double bonds, that is an excellent question. If you have 2 double bonds, for example, if you have this, that is the question somebody is asking. Okay, in this case, of course, this will be position number 1, position number 2, position number 3, and position number 4, and 5, and 6. Okay, in this case, you have to indicate the position of the double bond. So this molecule will therefore become 1,3. We will call this 1,3. In this case, you have to indicate the position 1,3 cyclohexa. Then you use the prefix di in. Okay, you have 2 double bonds. That is where the di comes in. 1,3 cyclohexadiene. That will be the name of this molecule. And somebody said, supposing you have a methyl group attached to it, then in that case you also have to indicate the position of the methyl group. Say we have this. Say we have this. If the methyl is here, if for example the methyl is here, then you have to start numbering from where the methyl is. So this will be carbon number 1. So this now becomes carbon 1, carbon 2, 3, 4, 5, and 6. And therefore the name of this becomes 1-methyl. 1-methyl. Then you indicate the position of the double bond, 1,3 cyclohexadiene. Okay, so that is the way you name this molecule right here. Okay, I hope that is clear to all of you. If that is clear, give me a happy face. Okay, very good. So in this case, whenever you have more than 1 double bond in a ring system, then you have to indicate the position of the double bond. So that was an excellent question. Okay, so now let us now come to this question here to name this molecule. So I am going to erase this. Okay, so let me write this molecule out. We have a carbon-carbon double bond right here, so let us do that. Methyl is here. Another methyl is here. And then you have this is attached to a CH. And that CH is attached to a methyl. And then this is also attached to a CH, which is attached to methyl and another methyl. Okay, so okay, I think there's an hydrogen here. So how do we name this? Well, the first question I want to ask is, what is the longest carbon chain that contains a carbon-carbon double bond in this molecule? What is the 6? Okay. Okay, let me call this my right side, and let me call this my left side. Where should I start to number this longest carbon chain? From my right or from my left? From my right. Excellent. That is correct. So I will start numbering from here because I want to assign the carbon-carbon double bond the lowest possible number. So that is 2, that is 3, that is 4, that is 5, and this is 6. Okay, so therefore we have branches. Okay, somebody has given us the name. That is great. Let me see here. We have branches in position number 5. Okay, you guys said 2, 4, 5 trimethyl. We also have branch in position number 4. Okay, that is the 4. We also have branch in position number 2. Excellent. And then the double bond is in the 2 position of hexene. Excellent. So the name here, I think you guys have already given us the name, which is great. So that is 2, 4, 2, 4, 5, methyl. Then you want to indicate the position of the double bond. Then you say 2. Then the parent name is hexene. Okay, so we are moving right along. Okay, no questions, so we will move on. Okay, how about this? How do we name this? Okay, let me go ahead and write this structure here. We have a 5-member ring. This is a 5-member ring. The double bond is right here. So let us do that. We have okay, so let us say the double bond is here. And then we have the isopropyl group right here. And then we have here on this carbon here, we have a methyl group. Okay, so the question that I have for you is, if I say this is the top and this is the bottom, where do I start numbering? Where does the number start? From the top or the bottom? Top. Excellent, excellent. Okay, so we have this here. 1, 2, 3, 4, and 5. So therefore, what is the name of this compound? Keep in mind, this is the isopropyl group. Okay, 1 isopropyl, 3 methyl cyclopentene. Excellent. Okay, so that becomes 1 isopropyl, 3 methyl cyclopentene. Okay, somebody is asking a question. Doesn't methyl come IJKLM? No, the I comes before M, so that is why we have isopropyl first. Somebody also said, let me see here. Somebody also is asking another question. Doesn't methyl come before? Oh, okay, I see. Okay, yeah. Okay, so the I comes before M. That is why the isopropyl comes before the methyl. Okay. We did not say, keep in mind, somebody is asking, how come I did not give the position of the double bond? Keep in mind, we said whenever we only have 1 double bond in the ring, we do not have to indicate the position, because it is assumed that the double bond in a ring system will always be in position 1 and 2. Okay. The branches cannot be counted into the ring system because it is not part of the ring system. Okay, so let us go to the next one. Okay, somebody is asking another question because the carbon, okay, let me see here. When numbering the carbons in a site, do you always have to go? No, you do not. When you do, when numbering the carbon in the cyclic ring system, you do not go either clockwise or counterclockwise. You number it to give the carbon-carbon double bond the lowest possible number. And if, like in this case, where the carbon-carbon double bond is also attached to an alkyl group, then the carbon that is attached to the alkyl group will be given position number 1. Okay. Those are some very good questions, by the way. Okay. Kiera, go ahead and read this question for us.
Assign stereochemistry E or Z to the double bonds in the alkenes below.
Okay, very good, and thank you. Okay, so now they want us to assign the stereochemistry E or Z to this double bond right here. So let me go ahead and write this out. So we have the carbon-carbon double bond. One is attached to a methyl group right here. And this other one is attached to a chlorine. And then this here is attached to carbon-oxygen double bond, and then hydrogen. Okay, that is the aldehyde functional group right here. And then this is also now attached to an isopropyl group. Okay, so what they want us to do now is to assign stereochemistry to this carbon-carbon double bond, the EZ stereochemistry to this carbon-carbon double bond. So what is the first thing we do before we do the assignment? Okay, I see the answer already. Okay, very good. But what is how do you get there? What is the first thing that you do? Prioritize, exactly, you prioritize. Okay, so we focus on this carbon here. Based on atomic number, we say this is A, priority A, and this is B. And then we come to this carbon here. We also now focus on this carbon, we give priority, and this is also this here. This carbon attached to oxygen and then also attached to hydrogen will be priority A, and this group here will be priority B. Okay, now we look at the priorities. The A are opposite to each other on the other side, opposite side of the carbon-carbon double bond. So therefore, we call this E. So this becomes E. So the stereochemistry here is E. And I think all of you got that right already. And this is what we call the Cahn-Ingold-Prelog easy system of nomenclature. Okay. Cahn-Ingold-Prelog. Okay, so let us go to the next one. Oh, somebody say, can I name this molecule? No, at this point, we do not want to do that because we have not done this class of compound. Until we get to this class of compound, nobody is going to ask you to name the molecule. Okay, all we can tell you to do at this point is to assign the stereochemistry E or Z to the double bond. Okay? Okay, how about this one here? How about this one here? Let us try this. We have a carbon-carbon double bond. Let me see here. Attached to another carbon-carbon double bond. Hydrogen is here. Hydrogen is here. Here is a methyl. And here, let us see here, on this side here, there is a methyl here. That is this here. That is this one here. And then we have, on this side, we have oxygen attached to a methyl. And here we have carbon-oxygen double bond attached to an hydroxy group. Okay, so what they want us to do here is to assign stereochemistry E or Z to the carbon-carbon double bond. So let me ask you here, can we assign stereochemistry to this carbon-carbon double bond here? Can we? Yes or no? No. No. Keep in mind, anytime you have any one of the carbon-carbon double bond, any one of the carbon atoms in the carbon-carbon double bond is attached to the same atom or the same groups, then you cannot assign E and Z stereochemistry. Okay? Okay, so let us and then we have this. Let us see here. So about this here, can we assign stereochemistry here? Yes or no? E or Z stereochemistry? Yes. So let us go ahead and do that. Let us go ahead and do that. Let us see here. So we focus on this carbon here. What is priority A? Okay, which is priority A? Let us say this, my right and my left. Which is A? The one on my right? Okay, exactly. The one on my right, you say that is A, therefore this is B. Okay, between this on my left, focusing on this carbon here, and this on my right, which will be priority A on my right. Okay, very good. So that is A, and this is B. So therefore, what will be the stereochemistry for this carbon-carbon double bond? E or Z? Z, because the two groups of same priority are on the same side of the carbon-carbon double bond. So therefore, this is Z. Okay? Why the top priority on the left? Why is it the top priority on the left? Okay, this one here, Well, I don't quite get that question, but this has to be priority A because this carbon is attached to oxygen. On the other hand, this carbon here is attached to carbon. So oxygen takes priority over carbon. Okay, very good, very good. So let us go to the next one. So we are moving right along. We are just about 8:30. Okay, now, okay, somebody asked a question for me. Go ahead and ask your question. Yeah, go ahead and ask your question. Okay, okay, nobody's asking a question. Okay, let us do...
on the last one, I don't understand on the second C why that isn't B. The oxygen attached to the methyl, why isn't that B?
This one here?
Yes.
Okay, okay. The reason why this is A, we're focusing on this carbon right now.
Mm-hmm.
No, stay on the line. Don't drop your telephone yet.
Okay.
Okay, we're focusing on this carbon right here. This carbon is attached to oxygen, okay?
Mm-hmm.
And then this carbon on this side is attached to carbon.
Oh, okay.
Oxygen takes priority over carbon.
Oh, okay, I was looking at the whole thing. Okay, thank you.
No. You have to take one carbon, one atom at a time.
Okay,
very good.
Thank you.
Very good. Okay, now let us go to this one here. Okay, I think I called on Kiara. Kiani Walker, can you go ahead and read this for us? Oh, is Kiani? Okay, Kiani is having problem with her mic.
Degree of unsaturation in the following formula.
Oh, okay, thank you. Okay, so the question is calculate the degree of unsaturation.
Can you hear me now?
Yes, I hear you. Yes, thank you. Okay, it said calculate the degree of unsaturation in the following molecules. And the degree of unsaturation, that is what I refer to as the index of hydrogen deficiency. And I give that the acronym IHD. And the formula that I wanted to use, for this formula is not in your book, and I don't think you will find it in any other book either. So the formula I wanted to use is this here, IHD equals to number of carbon atoms in the molecule minus number of hydrogen atoms divided by 2 minus number of halogen divided by 2 plus number of nitrogen divided by 2 plus 1. Okay, that is the formula I want you guys to use for the determination of IHD or the degree of unsaturation. Somebody asked a question for me. Let me see here. Okay, well, okay, let's move on. I didn't see the question. Okay, so now, this is the formula they've given us, C10. They have given us this formula here, C10, H16. So let us use this formula here. So therefore we say IHD equals to 10 for the number of carbon atoms minus 16 divided by 2, that is 8. Since we do not have halogen, which is chlorine, bromine, fluorine, or iodine, we don't need to worry about this factor here. We don't have nitrogen, so we don't need to worry about this. So we just say plus 1. Somebody has already given us the answer. That would be 3. Okay, so the index of hydrogen deficiency or the degree of unsaturation here is 3. Now the question I have for you is, what does this tell you? What does this tell you? Does it tell you, let us assume that this molecule only has double bonds. How many double bonds does this molecule? 3. Okay, supposing it has only rings. How many rings does it have? 3 exactly. Okay, or you could have a combination of rings and double bonds. Okay, so we have done that. Very good. Now let us do the next one. Somebody has a question. Go ahead and ask your question.
Hi, okay, so during, I think on Al in the book and in class, it said something like if you have 2 degrees of unsaturation that you are able to have a triple bond. How would you?
Yes. If you have 2 degrees of unsaturation, you could have a carbon-carbon double bond, a triple bond. Keep in mind that each carbon-carbon double bond is 1 degree of unsaturation. So if you have a triple bond, that would be 2 degrees of unsaturation, because for each degree of unsaturation, you are missing 2 hydrogens, and for the triple bond, you are missing 4 hydrogens. Okay, look at it this way. This here will be a molecule that is completely saturated right here. Now, if I remove one hydrogen here, 1 hydrogen from here, then I get a double bond. And that is 1 degree of unsaturation. On the other hand, if I remove 2 hydrogen here, 2 hydrogen here, which is a total of 4, then I have 2 degrees of unsaturation, which would be 2 index of hydrogen deficiency.
Okay.
Keep in mind, for 1 index of hydrogen deficiency, or for 1 degree of unsaturation, you are actually missing 2 hydrogens. Okay? And that is why we say it is double bond. Or
so if you had a degree of unsaturation of 3, you would be able to do 1 triple bond and 1 double bond?
Yes.
Okay. All right. Thank you.
Okay. Very good. Okay. Now let us do this next one. Let me go ahead and erase this. Okay. Here the formula they have given us is C17, 23 hydrogen, 1 nitrogen, and 3 oxygen. Okay, so what would that give us? Oh, now maybe. Let us work it out. Okay, so we have IHD equals to 17. That is for the number of carbon atoms, minus 23 divided by 2, that is 11.5. Okay, there is no halogen, so we don't need to worry about this. We have 1 nitrogen, so that is plus 0.5, then plus 1. So what would this be? Okay, to me, that seems to me like that would be, that's 6. That is 6. Okay, so the index of hydrogen deficiency here, or just like your book would like to call it, the degree of unsaturation here will be 6. So there is all kind of combination that is possible here. Okay, so this is 6. Okay. Okay, let's go to the next one. Okay. Now let us do this. I think we still have 20 more minutes to go. We are right on target. Okay, let me see here. Brianna, Neil, can you go ahead and read this question for us?
How many hydrogens are in C5H7N4, which has 4 rings and 0 double bonds? How many hydrogens? Oh, my bad.
Yeah, thank you. Okay, actually, that was Brianna, Neil. Thank you very much. Wait, I got 7 for. No, the answer to the last one is 6. So I think you need to recalculate your math, your arithmetic. Anyway, the formula they're giving us here is C5. They have C5. Now what they've done here, they have hydrogen. This is not 7. It is actually a question mark. They are asking you, how many hydrogen does this molecule have? Okay, that is what they are asking us to do. How many hydrogen does this molecule have? Okay, many of you say 7. Let us go back to the last one. Maybe my math is wrong. Let me just give me 1 minute here. Let us go back to this last one. Is that right? This is plus this. That is 12 minus. Wait a minute. Okay, 12 minus 12. That is. It should be 6. Where do you get 7? That should be 6. This is 11.5 plus 0.5. That is 12. 12 minus 17 minus 12. That is 5 plus 6. Should be 6. Okay. Okay. So now, what they want us to do here? This formula is C5. Instead of giving you the number of hydrogen, they put a question mark there. So it isn't 7. It is a question mark. Then you have nitrogen, 4 nitrogen. So this is another way of asking you, how many hydrogen do you have in this formula? Keep in mind, they're giving you that this molecule has 4 rings. So in essence, they have given us the index of hydrogen deficiency. So what they want us to do now, we have IHD equals to 4. That is what they're essentially telling you, because it has 4 rings. If that is the case, which equals to, let us use the formula again. Carbon atom, number of carbon atom, let me write the formula here. IHD, because you need to know this formula. Number of carbon atom minus hydrogen divided by 2 minus halogen divided by 2 plus nitrogen divided by 2 plus 1. Okay. The more we write this down, the more you will remember. Okay, so now, number of carbon atom here is 5. Hydrogen is a question mark, so we don't have it. So therefore, that is minus hydrogen divided by 2. And then we have for the halogen, there is no halogen, so we don't have to worry about this. And then we have 4 nitrogen, so that is plus 2, and then plus 1. Okay? If we work this out, so that means therefore 4 equals to 5 hydrogen divided by 2 plus 2 plus 1. So if we move this factor to the left, if you remember your math, so that becomes hydrogen divided by 2 equals to, and then we move the 4 to the right, that becomes 5 plus 2 plus 1 minus 4. Now if you work out that math, that becomes, what is that? That is 8 minus 4, that is 4. So therefore, the number of hydrogen divided by 2 equals to 4. So therefore, hydrogen equals to 8. So that is what they want here. So therefore, the formula they wanted to give here is C5H8 and 4 nitrogen. That is what they're asking. Do you follow that? If you follow that, give me a happy face. So you could see how you use this formula here. They could ask you this question in so many different ways. So this formula is really very important. Okay? Okay, now let us do the next one. Let me go ahead and erase this. Okay, we still have about 15 more minutes to go. For that, the reason I say you should remember that formula, I don't think you will find that formula in most organic chemistry books. Okay, so let us do this one here. Let me call on Lorena. Go ahead and read this for us.
How many hydrogens are in C13H (N), which has 4 rings and 6 double bonds?
Okay, how many hydrogens are in? Very good, thank you. The formula they have given us here is C13, and then there is a question mark and 1 nitrogen. So in other words, they are asking you, how many hydrogens do you have in this molecule? Okay, that is what they are asking here. Okay, so let us use the formula again. They also told you the molecule has 4 rings and 6 double bonds. Okay, so what is the index of hydrogen deficiency? Okay, 10. Excellent. Okay, so therefore, what they want us to do, therefore, let us do the calculation. That means 10 equals to the number of carbon atoms, which is 13, minus the number of hydrogen divided by 2. We don't know the number of hydrogen, so we have to say hydrogen divided by 2. There is no halogen, so we don't need to worry about this. There is 1 nitrogen, so we worry about that. So that is plus 0.5 and then plus 1. Okay, can anybody work that math out for us? I'm going to move this to this side. Move the hydrogen over 2 to the left. So that means hydrogen divided by 2 equals to 13 plus 0.5 plus 1, then minus 10. Since we are moving this 10 to the right, if you all remember our math. Okay, so what does that give us? So that gives us, what is this here? That is 4.5. So therefore, hydrogen divided by 2 equals to 4.5. Therefore, hydrogen equals to 9. I think somebody already gave us the answer. Okay, all of you got that right. Excellent. So you can see this formula is actually an excellent formula to remember. Okay, so that is the number of hydrogen here is 9. So the question mark here, therefore, let us remove the question mark and simply put 9 here. So the formula is C13, 9 hydrogen and 1 nitrogen. Okay, very good. Let us do one more problem before we go. I think, let us see. Okay, I'm sure you guys will like this. Ines Kifando, can you go ahead and read this for us?
Draw a structure for 3E, 5Z, 2,6-dimethyl, 1,3,5,7 octatetraene. Okay,
thank you. Very good. Okay, so what they want us to do here, to draw the structure for this molecule here, 3E, 5Z, 2,6-dimethyl, 1,3,5,7 octatetraene. Okay, the question I have for you is, how many carbon atoms do you have in the longest chain of this molecule? 8. Okay, so let us go ahead and do that. Draw the 8 carbon atoms. So I will say, I'm doing this here in order to break this down for all of you. So you can follow this. That is 6. Okay, so that is 8. Okay, now they say that in position 1, 3, 5, and 7, let us number this. Let us say this is position 1. Let's say 1, 2, 3, 4, 5, 6, 7, and 8. So position 1, they say there is a double bond, okay? So that's why they say 1 right here. So we have a double bond here. Position 1. That means there is hydrogen. Okay. Position 3. Another double bond. Position 5, which is here, another double bond. Position 7, which is this, another double bond. Okay. Now let us look at the branches. They say in position 2 and 6, we have methyl group. Okay, position 2. And position 6. Okay, say methyl here. Okay, so those are the skeleton that we have now. Let us now add the hydrogen to make up the rest of the molecule. Okay, so hydrogen is here. Keep in mind, carbon must have 4 bonds. So, okay, now we also must have hydrogen here, right? We also must have hydrogen here. Okay. Also, we must have hydrogen here. Also, we must have hydrogen here. And on this carbon here, 2 hydrogen, in order to make up for the valence of 4 for carbon atom. Now, the next thing that we need to address is we want 3E, 5Z. Okay, so let us look at this here. 3E, okay. So go ahead and ask your question. Go ahead and ask your question. Okay, nobody said. Okay, go ahead. Okay, now let me continue here. Now they say it must be 3E. Okay, the way we have this here, let us look at these 2 carbons here. Let us assign the priority and see whether we have 3E here. Okay, if you look at this carbon here, okay, this group here is priority A, and hydrogen is priority B, right? If I look at this carbon here, this group here, right here, is priority A, and this here is priority B. Okay, what do they want us to do? So what is the stereochemistry here? Is this correct? Is it 3E or is it E or Z? Exactly. So what we have here is correct. It just so happens that what I have here is correct. But if, for example, if I had written the hydrogen here, that would be Z. Then what I would do is to erase it and place the hydrogen here. Okay? So therefore, this is correct. This stereochemistry that we have here is correct. That is good. Now we now go to, they say 5Z. 5. This is this one here. Okay, go ahead and ask your question. Okay. Whenever you click on that electronic hand, I do hear a loud bell in my speaker, and that tells me somebody is trying to ask a question. So that is why sometimes I say go ahead and ask your question. Okay. So in this case, this here is E. This here is E. Okay. Oh, okay. Now let us now try this one here. What is this one? The stereochemistry here. They say it must be 5Z. Okay, is this what we have here? Let us see. Let me go ahead and erase this. Okay, let us assign the priority. Okay, if you look at this carbon here, okay, this is priority A. This group is priority A, and this hydrogen is B. And then if you look at this carbon here, this group here is priority A, and this methyl is priority B. Okay. Okay, it just so happens this is also correct. Okay, the 2 lower priority are on the same side of the double bond, so that is also Z. Okay, so it just so happened that the way I wrote this, it was the correct stereochemistry. If, on the other hand, if when you write this, it is not correct, then just go ahead and erase it and write the correct stereochemistry. Okay. Okay, very good. Okay, so now I think this question is already answered. We have 5 more minutes to go. Let us see, do we have time for another question? Okay, the last one. Okay, let us do this and that will be the end of today. If I have not talked to you today and your mic is working, can you pick up the mic and read this for us? Anybody?
Provide the
IUPAC name for this compound.
Okay, very good. I see Valerie and Amber reading the questions together. I thank both of you. Okay. It says provide the IUPAC name for this compound. Okay, keep in mind when they say provide the IUPAC name, in this particular instance, they also want us to give the E and Z nomenclature. Now, this is something I want to tell you. This is a little bit more complex for you. This group here, before we answer that question, whenever you have this group, this here is called a vinyl group. Just as you have a methyl group. So anytime you see this group in a molecule, okay, you could call this a vinyl group. So in this regard, let us look at the longest carbon chain in this molecule. Let us look at the longest carbon chain in this molecule. And also, whenever you have this, group, which is right here, you call that a methylene group. A methylene group. Okay? So now you have in this molecule, you have a methylene group. You have potentially a vinyl group. So the tricky question here is, which is the longest carbon chain containing the most number of carbon-carbon double bond? Let us see. Okay, where do you start numbering? Do you start numbering from here or from here? Where do you want to start? Okay, if you start from here, say top. If you start from here, say bottom. Okay, somebody say 12. Yes. Yes. Okay, very good. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So the longest carbon chain here is 12. And therefore, we are going to consider this here as a branch. This methylene group, we're going to call this a branch. Okay? So what do we have? We have the longest carbon chain. It has to be how many double bonds we have here? 1 within the chain. 1, 2, 3. Okay? So what will be the name here? And then the branches are, we have a branch here on carbon 7, a branch on carbon 11, and another branch on carbon 3. Okay, you say the longest carbon chain is, okay. Oh, what did I do here? I'm sorry about that. Sorry about that, folks. Let me come back to here. Okay. Okay, I am back. Okay, sorry about that. I think I pressed something. Okay, so let us name this. We need to get out of here. So this becomes, okay, methyl is in 3 position, methylene. So we say methylene. Okay, that is 3 3 methyl. That was not 3 methyl. That is methyl is in the 7 and 11 position. That is 7, 11 dimethyl. Okay, then 3-methylene. Okay, and then the longest carbon chain is 12. We have carbon, the double bond in position 1, in position 6, and position 10. So that becomes 1, 6, 10, do, deca, tri, in, because we have 3 double bonds. Now, we also need to indicate the easy nomenclature. You notice here, we don't need to worry about easy nomenclature here, so we don't need to worry about this. Also here, we don't need to worry about easy nomenclature here, because this carbon is attached to 2 methyl groups. We only have to worry about easy nomenclature right here. So let us do that. I think it is 9 o'clock, so we need to get out of here now. Okay, so what will be the nomenclature as stereochemistry here? Okay, keep in mind this is, anybody know? This is a CH3, this is hydrogen. What will it be? Okay, okay, let us look at this carbon. This is A, and this is B. Now let me change the color. This is A and this is B. On this carbon here, this is A and this is B. So therefore, what would that be? So that would be Z. Parent Z. Sorry, parent 5, 6Z. That's, yes, that's 6 carbon. That is parent 6Z, then 7, 11 dimethyl, 3-methylene, 1, 6, 10, dodecatriene. Okay, folks, I know we all need to go and watch the presidential debate. We have come to the end of today's session, but if any one of you want to stay for another 5 minutes, I'm going to turn the recorder on, and I will stay on for 5 minutes, and then we will all leave. Okay, for those of you who are leaving, enjoy the rest of your evening, unless you want to stay with me for another 5 minutes.
Professor, I have a question.
Okay, go ahead.
Okay, hold on. Hold on.